Hey, my name is Neff, and well, first of all, to all my new subscribers that come from the Michael Reeves parody video, welcome! It's nice to have you here. There's a little thing that you need to know about me. Yeah, not all my videos are of that quality, so I hope it doesn't bother you that I'm not gonna be making, those kind of videos that often. I still plan on making those, but that's another story for another day. For my other viewers / subscribers, or even for them, what are we doing today? Well, today I wanted to talk a little bit about sorting algorithms, okay? Now, sorting algorithms, they're that's a very extensive topic that I cannot possibly cover right here in a single 20-minute video or whatever this video's length is, right? So they're very extensive, but what we're gonna do here is we're gonna do a comparison. Now, in my job, for one reason or another, I sometimes need to use this programming language called Python. Now, Python is a very interesting programming language because it's not really a programming language. It's more like a pseudo language. Like it's kind of like pseudocode. But you can execute it, you can create scripts on it and run them. It's an interpreted programming language. It's a dynamically typed programming language. So I don't like interpreted programming languages because catching errors is a lot more difficult there, and I don't like dynamically typed programming languages because I feel like they kind of hold your hand a little bit too much. I want my compiler, I want my IDE to scream at me when I'm doing things wrong, right? Why? Because overall, I feel like the finished product after that is a lot more polished than with an interpreted programming language such as Python. Anyways, but I still need to eat, okay? I still need to eat, so sometimes in my job I do end up using Python. And this was one of those cases. Now, I wanted to do a little comparison between Python, which is a language that I hate, and my favorite programming language, that is C#. Now, it's obviously going to be faster, okay? I want to show you guys that C# is faster, but you don't need me to tell you that. That's a fact. I want to show you just how faster C# is, okay? So yeah, that's what we're doing today. I don't think I'm gonna edit this video at all, or I'm gonna try not to edit this video at all. So right now, right here, I have both a Python and a C# program with almost the exact same layout. So what we're doing here is we're basically generating 20 random, we're generating 1,000 random numbers each for like about 20 times. We're iterating 20 times in a for loop. Let me check where that is. Here it is. So we're iterating 20 times in a for loop. Here is that right here on C#, okay? And what we're doing is we're executing one test each of those iterations. What is the test that we're executing here? Okay, it's actually very easy. We have around 4 different sorting algorithms. We've got the bubble sort, we've got the insertion sort, we've got the selection sort, and we've got the merge sort. On Python, I also included the standard sorted algorithm, which is the TIM sort. It's a combination between the merge sort and the insertion sort, I think. But we're not gonna go over that one. So what we're doing here is we're gonna compare how long it takes for each of these programming languages to sort a list of 1,000 random elements with each one of these sorting algorithms 20 times, okay? And we are benchmarking the how long does it take for these functions to complete, At the end, we're going to take a look at the average times and the total times of each of these sorting algorithm iterations to get more or less an idea of how fast each of these programming languages are, right? So it's a very simple thing. Let's just quickly run it. Another rule to have in mind: the programs have almost the exact same layout, as I said. So this, for example, if we go to the bubble sort here, I think this is very apparent. If we check my C# code for the bubble sort, it's very similar to my Python code for my bubble sort. So I'm trying to make my C# as close to my Python, because I want this comparison to be fair, right? So we're executing almost the exact same instructions, okay? Or, well, as close as the exact same instructions as we can get. So you can take a look at my code. I'm gonna leave my code in the description. You can take a look at it to check that the codes are roughly the same. Anyways, so let's quickly execute this code. We have the Python program running for 1000 elements. On the C# program, I actually need to specify that amount, so 1000 elements, okay? And here, as soon as I click enter on my Python program, that's gonna run, all right? So we're running that, and we're running also the C# script. And right off the bat, the C# script is already done, and the Python program was still going. Now, the Python program has finished. Let's take a look at the information, at the output information that we got. Now, before we go any further, you can actually check that this is completely listed with, completely sorted with selection sort, with insertion sort, with bubble sort, and with merge sort. There you go. And if we go to the Python output, it's exactly the same, with the added bonus of the default sort, but this does not affect our benchmarks for the other algorithms. So merge sort, we've got here selection sort, we've got insertion sort, and we've got bubble sort. Okay, perfect. So let's take a look at our time outputs. Here we have on the Python program, the bubble sort took an average 4.45 seconds. That is, for each iteration, for a total of 20 iterations, this is what it took on average to perform that sorting algorithm, 4.45 seconds, okay? And if we go to our C# code, for our bubble sort, it took 0.0785 seconds, okay? And this I want to remind you, this is the worst sorting algorithm, other than probably Bogle sort, but this is the worst sorting algorithm of them all, okay? And it took 0.0785 seconds against the 4.45 seconds that we have in Python. Now, we can see a similar trend with the other algorithms. So, for example, insertion sort took 1.1626 seconds in average, and insertion sort performed right here on our C# program with an average of 0.0025 seconds. Okay. Selection sort took an average of 0.6389 seconds on Python. Selection sort on C# took 0.0016 seconds. Okay. Merge sort. Now this is where things get interesting. Okay. So merge sort in Python took 0.05798 seconds. That is pretty fast. Okay, merge sort is an algorithm that has an average time complexity of O(n) log n, which is the, as I understand it, it's the best possible scenario, other than, you know, O of n, for a sorting algorithm. So that's what it took, okay? So 0.0579. Now, if we go to the merge sort measurement that we did here with C#, we can see that it took 5 times 10 to the minus 5 seconds. Okay, to the minus 5. That is, okay, it doesn't give me the amount of zeros, but it's basically 0.1005. I mean 0.505 seconds. That is extremely fast. That is insane. And this is how they perform. And again, they are playing by the same ground rules. Okay, there's nothing going on here that is unfair. If anything, C# is at a disadvantage here because the C# program that we're building is the debug version, and the debug version actually takes more time than it would for a release version of this exact same code to run. Okay, so that's our information in terms of the program that we ran. Now I ran a little tests. I ran some other tests here for our sorting algorithms. So first, I ran the Python script with around 10,000 integers. Okay, 10,000 integers, and these are the results that I got. You can see the raw results here. You can see a graph of the average in the total times that it took, and the execution differences between each sorting algorithm. We also have that here, and here's a table for our sorting values. So again, this is with 10,000 values, okay? 10,000 values, Python took 528 for the bubble sort, this for the insertion sort, so on and so forth. You can take a look at the table and start to see some patterns here of which algorithm is actually faster. Of course, the fastest algorithm here in Python would be the default sort with the merge sort right behind it. But if we go ahead, this is again 10,000 elements, okay? And for 30,000 elements, we have the exact same data. This is the table for 30,000 elements. Now, I wanted to run 100,000. I wanted to sort 100,000 elements 20 times on each of these programs. Okay, I wanted to sort 100,000 on the Python program and 100,000 on the C# program. What's the problem? Python takes absolutely way too long to sort them. Okay, like I cannot even begin to explain how slow Python is. Okay, perfect. So that's the table for our sorting algorithm with 300,000 elements. I mean 30,000 elements. Now, 100,000 elements. I only did this with C#, and here are the results. The bubble sort performed with an average of 150.25 seconds, which means it roughly took over. It roughly took over 2.5 minutes to complete each iteration of the bubble sort. This is, again, one of the worst sorting algorithms in the history of Earth, running over a list of 100,000 elements. I think that does deserve some credit, okay? Now, let's take a look at the average and total times. These are the execution differences, and here is a table with all the data for these algorithms. Now, you can already see the difference between C# and Python. If you look at the scales, let's check just the execution differences graphs right here. If you look at the scale of this graph, it goes up to 600. It doesn't even touch 600. So it goes from minus about 450, minus 500, something like that, to around plus 500. Around those values, okay? So that's the lower and upper bounds of this graph right here for execution differences. for each sorting algorithm, and for the execution differences of each algorithm on the Python script with 70,000 less elements each iteration, we get from around minus 5,000 to around plus 5,000 plus 6,000. So those are the upper and lower bounds for the Python script with less than with 70,000 less elements. I don't know, man. If that does not convince you to not use Python for your big projects, I don't know what will. Now, C# can be a beast in terms of speed, but it's nothing. It's nothing compared to C++. The only reason I didn't write this in C++ is that I don't have time at the moment. But, I mean, C# is my favorite language, but I'm not biased here. C++ would absolutely destroy both Python and C#. C# would barely even manage to be comparable to this exact same algorithm ran in C++. Especially C++ 64 bits. Anyways, that's the video. I'm gonna leave you guys a link to the document that I used here. It's kind of like a little paper. I wouldn't really call it a paper, but it's kind of like an explanation for sorting algorithms. I'm a programming tutor, so I did this for one of my students. And yeah, that's I'm gonna leave you this information down in the description, as well as both the Python and the C# code for for this project, so you can recreate it on your own, and you can actually test if it's better or not. So yeah, that's it. Thanks for watching. See you next time.